Hello, everybody. I'm recording now. I'm just reviewing what we did at the very end of class. So this question, we have an amplitude of 1/7. Amplitude means if you had a center line, that would mean that the function was to go up by 1/7, so a seventh. So this would be a really small function, really tiny amplitude. Period means how far or how much time it takes to go from one peak to the next peak. So for example, if this was our function, from one peak to another, in this case would be 5π/3. That would be our period. That's the distance or the time it takes to get from those 2 points. Of course, you can do any 2 points as long as they're the same point. So here, this point would match this point over here, and that period would also be 5π/3 between those 2 points. All right, so this is the main idea. Of course, this is just a bad sketch. It's just to give you the idea. And finally, displacement, d, also known as phase shift, phase angle, things like that. In this case, displacement is 0. What displacement means is if you had your regular sine functions look like this. They have a y-intercept right at the center. Displacement of 0 means that it hasn't been shifted left or right. If the displacement was 2, then it would have been shifted to the left. If the displacement was like something like -2, it would have been shifted to the right. But in this case, we don't have any displacement. So I just wanted to quickly recap that in the shortest way I could. So what value are we looking for here? What are we trying to do? Well, we're trying to figure out this equation. And this equation has 3 distinct pieces that are important. It has an A value, a B value, and a C value, all relating to the 3 things that I just talked about. So, can someone tell me how I get A? You know, if I'm given A here, how do I get A? Well, A is just the same thing. Amplitude is little a. It's the same thing. So you can always just steal that and take that number. So that'll go right here on top. Period is a little bit trickier. Does anyone remember the formula for period?
2/b.
2π/what?
Over B.
B. Okay. So the problem is we don't have B. We're looking for B. So let me just make this clear. Period is 2π/b. And so if we're looking for B, all we need to do is rearrange that. So we can say that B is actually just 2π/p. You can take that, you can memorize this as its own formula if you want to. So B is 2π/period. And in this case, our period is what? It's 5π/3. Let me make that a different color, 5π/3. So many students have trouble with that. I tried to give you an easy way to do it yesterday. The easy way to do it is this. Just take that 2π. We know it's divided by 5π/3. If it's divided by 5π/3, that is the exact same thing as multiplying by 3/5π. Multiply by the reciprocal. It's the exact same thing. I won't go through why that works. I'm just going to tell you that it always works. This gives us, what's 2π times 3? Well, 6π. And on bottom, we have 5π. So actually, I should just cancel these pi's right away. And it will be 6/5. Okay, so that's our B value. So we already have A and B. We have A, we'd put that in there. We have B, we'd put that in there. And now all we need to do is get C. So for those of you that don't know where this question came from, this is just this question here. I just wanted to give myself more space. Okay, let's do the very last one. The last one is, we need C. So displacement, or D in this case, call it what you want, phase shift, it all means the same thing. It's related to C. We know the formula for this. You remember this one? There's 3 formulas given earlier. I'll bring you to it, just in case you missed class, you can find it. Oh, here it is. Amplitude, A. Period, 2π/b. displacement, negative C over B. So if you have C or B, it's easy. So it's negative C over B. Well, our displacement is 0. Our displacement is 0, that means C is 0. Now we have our 3 pieces. So our final answer here I'll write out. Therefore, y is a, 1 over 7, sine bx, b is 6 over 5, plus c, and plus 0. So there's nothing to add. This is our final answer. So that was a review of yesterday, what we did yesterday. I hope I didn't go through that too quickly for you. I just wanted to make it as clear as I could. Let's, just for example, say that displacement was pi over 2. Let's just say for an example, what if displacement was pi over 2? Because I want you to be able to handle that. So what you would say, we would have negative c, let me just split this up. Negative c over b, we know that's displacement. We also know that displacement is pi over 2 in this case. All right, and from earlier in the question, we found b. So let me make this very clear. Negative c, c is what we're looking for. B we have, it's 6 over 5. And pi over 2 was our, what am I looking for? Pi over 2 is, oh yeah, our new displacement. Okay, how do you solve this for c? So to be very clear, you're going to have to solve something like this. How do you solve for the c value, just the c? I showed you it yesterday quickly. I want to make sure you know how to do this. The fastest way is to take the 6 over 5, multiply it by everything. Or in other words, move it to the other side. Pi over 2 stays where it is. Multiply all that by 6 over 5, and we have our answer. I'm just going to put a negative on this, of course, because there's a negative. And then you multiply through, and you're done. So on top, what's negative pi times 6? It's negative 6 pi. On bottom, what's 2 times 5? It's 10. And then that can simplify. You know, put it into your calculator or something. You should get negative 3 pi over 5. Okay, so I just wanted you to be able to handle a question where there's fractions kind of thrown all over the place. There's fractions on top, there's fractions on the bottom. How do you handle those? Well, now you should be able to handle it. Okay, so that's a review of what we did yesterday. Is there anything that I can go through on this before I move on to the next topic? Have I scared you all out already?
No, sir.
Okay. Sorry, I'm a little bit overwhelmed because I spent this afternoon going around and looking at this new apartment, new villa, and it's extremely hot outside. And my car doesn't have very good air conditioning, so I came back and I like, anyway, that's why I'm kind of flustered. It's not the max. Yes, how are you doing?
Fine, thank you. Mr. I have a small problem that when I print the papers, the notes, there's no numbers for the pages. So you have to like wait a little time to find the page.
It's fine. So we're starting on this page. This is page 23. I know you don't have 23, but can you find it where it says sine, cosine on top?
Okay, 1 minute.
It's page 23, so it's about a little over halfway through the notes.
Okay.
Okay. While Ahmed is doing that, I want to make sure you all know the assignment's tomorrow, right? It's the last 40 minutes of class. I'll give you 30 minutes and then the extra 10 minutes probably. It shouldn't take that long. It's one double-sided page. And there will be some graphing like we do today. So make sure that at least you have graph paper or you're very, you can find some way to just draw it on your notebook. But there will be graphs, okay? Just so you're prepared. Okay, so I'm going to move on to the next topic. Mr. Tom took quite a long time explaining this in his YouTube videos, which is excellent. Those are like your fully detailed videos. I'm going to give you what I think is an equally good method, but just cover it in a faster way. Because these topics, the next two topics, there's not a lot to them. So let's get started. We're going to graph sine and cosine. So we need to graph functions that look like this and functions that look like this. The same functions that we were dealing with earlier. Okay? So it says in the last lesson, we of course covered all these three things. We did this before. In this page, really all you need to worry about, it says in this lesson, we'll use the above properties to sketch the graph. In attempting to sketch the graph, we need to locate the position of 5 key points that outline a single cycle. So what it means, we need to go up and down, and then, once we're able to start again, we can stop. And the method just takes 5 points because that will fully describe the function. If you look down in this area here, you'll notice there's 1, 2, 3, 4, 5 points. This is for a sine curve. That is enough. If you only had these 5 points and they looked like this, you would be able to connect the dots. Now, of course, don't do this. That's not a sine curve. You would just sketch this and you would have your curve. So we only need 5 points. And there's a very standard method for getting those 5 points that's the same every single time. You just need to find the same stuff that you found before, amplitude, period, phase shift, and use those. They'll help you find your points. So I'll show you how that's done, okay? 1 second, I need to turn off my phone because I'm blown up. I'm too popular. So the 5 points you need, you'll notice that there is a 0 value, a maximum, another 0 value, a minimum, and another 0 value. This is our maximum. This is our minimum. Go up by the amplitude, come down by the amplitude. They'll give you your maximum, minimum. The most important piece of information in this whole section is this table. If you know this table or you have it as a reference, then you should have absolutely no trouble doing this part. It's like our cheat sheet. Okay, so this is important. I'll just highlight this. You need to know that this is our period formula. If you want to get the distance between 2 points, it's period divided by 4. And how we find our points, our x values are found by getting the displacement and then adding that distance each time, 4 times. Let me show you what that looks like. Let's just say that this is our first point, okay? This point here, let's just say that's our first point, this blue point. If we go over by the period, go all the way over by the period, we'll start again. So our 2 points are easy to find, our endpoints. You have the original point. If you add the period, you'll get to the end of the function, because that's the definition of the period. That is, it's the whole function. So from start to finish, just add the period. And you'll notice here, there's these lines. What if we cut the function into 4 pieces? So take the period, divide it by 4, and what we see is this distance is period divided by 4. This distance is period divided by 4. This distance is period divided by 4. And this distance is period divided by 4. They're just 4 sections that make up the period. So of course it's pi over period over 4. So you can break this down. It should make sense. But again, even if you don't understand what I'm saying, the table will help you. So let me look at both at once. It starts with displacement. That gives you your initial x value. The y value will be 0 for the sine curve. You'll add the period divided by 4. That'll give you your second point. That's where your amplitude is going to be. That's where your maximum point is going to be. If you do it again, you'll get a 0 point. You add the period over 4 again, you'll get the minimum point. Add the period again, you'll get the 0 point. So let's do it, okay? I'm not going to do these examples because these examples are a little bit ugly. They don't work out really nice. I'll let Mr. Tom's work do that if you want to go and see them. I'm going to jump to the practice questions. So I'm going to jump around a little bit. Sorry, Ahmed. Practice 1. This is on page 29, or the page that starts with practice 1 on top. It says, sketch the following trigonometric functions, so sine or cosine and so on. For each, state the amplitude, the period, and the phase shift. which are normally amplitude, period, phase shift. Also, the 5 key points should be indicated on the sketch. Okay, so we get the 5 key points from our A, B, and C period and stuff. So just follow me, and you'll see, I hope, that this is quite easy. So A, what is our A value? Well, that's simple. Our A value is 0.5. I'm going to go ahead and do B and C as well. So what's B? B is the number next to the X, it's 3. Our C value, I don't have a nice color that I am happy with today. Our C value will be pi over 3. All right, those are our 3 numbers that are important. Those are these 3 numbers here. Come straight from the graph. The amplitude, 0.5. All right, 0.5. Or 1/2, right? Whichever one you want. We can already fill in 5 things in the table. And how I know this is because the y values come directly from our amplitude. For sine, when we have sine, it'll go in this order. 0, 0, 0. So actually, we can put those in already. 0, 0, 0. Those are always 0. You get them for free. You're welcome. The second one is just the maximum value. So what's our maximum value? It's 0.5. It's the amplitude. And the fourth value here is the minimum value. What's our minimum value? It's the same as the amplitude again, but down. So it goes up by 0.5 and it goes down by 0.5. You'll see how this all connects when we make the sketch. It's not too bad. So what else do I need? I need these x values, and I can't get the x values unless I have the displacement and the period. The displacement will give us our first x value. The period will give us our other 4 x values, and then we'll be done. So let me be clear. On the assignment, you will only be given this table. You should know how to get the points yourself. Now, of course, if you're smart, or sorry, if you're thinking clearly, you should go and have your notes in front of you and use this. This will tell you everything you need to know. Or you can memorize it and understand it. It's up to you. Let's get period. How do we get period? Well, period, we already talked about, is 2 pi over b. In this case, b is 3. We know that b is 3. So 2 pi over 3, that's all we need. There's nothing to simplify. Period is 2 pi over 3. Let's go one step further. Period divided by 4. What's period divided by 4? Well, it's 2 pi over 3 divided by 4. Not a lot to it, really. What's 2 pi over 3 divided by 4? Some students can't do that, you know? Take your calculator. You can hear me, yeah? My computer tells me sometimes that you can't, but I don't believe it. Take the calculator. I showed you this yesterday. You can set up your fractions. Say 2 over 3. I would do this. I would take the fraction first, get your answer, and then divide it by 4. It's 1 over 6. So our answer is pi over 6. So Ahmed Al-Aswad, it's 1 by 6. You got it. Just make sure you don't forget to put the pi in. All right? That's our period divided by 4. So let me be very clear here. That's the distance between the points. That's the amount that we'll add each time. So whatever we have here, we'll add that number for each of these, okay? That's how this works. So it says right there in the cheat sheet, that's what we do. We have our displacement, we add the period divided by 4, add the period divided by 4, and so on. I'll do a few of these, you'll get used to them. So now that we have the period divided by 4, we need to get the phase shift. That will give us our displacement, okay? Whatever we get for phase shift, we'll take it, and I'm going to put it in right there, and I'll be almost done. So I'm going to call it displacement, d. I'm going to write our formula, negative c over b. We have C and we have B. So just put them in. Negative, well, C is pi over 3 divided by B. B is 2 pi over 3. So notice, like I said, there's a lot of fractions work. You should be very careful with this. Either use your Casio calculator carefully, or you can do it by hand, which honestly sometimes is just as easy. So I'm going to show you how to do it by hand. Negative pi over 3 is on top. Write that first. And I'm going to divide it by 2 pi over 3. So far, that doesn't help us. What I can do is change it to a multiply and get the reciprocal of the second one. So minus pi over 3 times multiply 3 over 2 pi. And now I'm in business, okay? I've got pi. They cancel on top and bottom. What do I have? I have a negative 3 on top, and I have a 6 on bottom, which is negative 1 over 2. So actually, you're getting pi over 9. Was that for this question, or did I do something wrong? Let me check it on the Casio. I'll double check, because I haven't done this one out myself yet. Let me see. Clear what I got. Fraction. Gonna make another fraction on bottom. Got my whole story being told here. And let's see, I'll put negative pi on top. I go down, put in a 3. And I go down, put in a 2 pi. They'll cancel. You don't even need to put them in, but I put them in anyways. And a 3. Let's see what it gives us. Negative 1 over 2. So I had negative 1 over 2. Calculator has negative 1 over 2. So I think it's right. Maybe you made a small mistake along the way. Not sure exactly where, but take a look at your work and make sure you find that mistake. If you can't find it, just let me know. I can help you find it.
Mister,
Yes.
I have one idea or one hint to help you with this. Not you, I mean.
Yes.
If we have fraction over fraction, we just multiply the far with the far and the close with the close. The close number with the close number and the far number with the far number.
Yeah, so what you're saying, I'll rewrite it just so everyone, if they want to use your trick, they can, because there's nothing wrong with it. So you're saying multiply this by this.
Yes, the far with the far.
And get negative 3 pi divided by the close with the close, or multiplied together, yeah?
Yes.
That works. Nothing wrong with that. That's good, and then that simplifies. Perfect. Just as fast, yeah, probably faster. Yeah, no problem, use that. If you want to use it, you can use my method or use that method. They're both the same, really. Yours is neat. I've never seen it done that way before, so that's a new tool for me. Maybe I'll teach it like that next time. Okay, so the whole point was once we get that displacement, the whole reason we got the displacement was to fill in the table. Now our first x value is going to be negative 1 over 2, and our first y value is 0. So if I wanted to, I could already graph this. Just for fun, I'll do that now. My first x is negative 1 over 2. Just 1 second here. I want to bring up my reference so that I don't make a mess of things. I'm looking at my notes and I'm seeing a small, oh no! Ayesha was right the whole time. Okay, so this was a good practice to get used to the algebra, but I made a huge mistake. And this is the only mistake I make over and over again. I've got to erase all this. Sorry, everybody. You can just put a line through it and go under. The b value is 3. It's not 2 pi over 3. That's period. I knew something was going wrong. I could feel it in my bones, but I didn't get it in time. So I'm very sorry about that. I've wasted a little bit of your time, but I think to get this skill out of it was actually worth it, because there are questions like that that come up. So Ayesha was right the whole time. My bad. We have negative pi over 3 times 1 over 3, which is negative pi over 9. You can also, if you wanted just to do Ahmed's method, you could just take this and multiply by that. Multiply the bottoms together, which is just as good. So sorry about that, everybody. I'm going to have to make a little change here. I've made a few mistakes the last few days. It's almost like I'm human. It's weird. I'll put that in, and then it goes here. The next time I do this, I won't make it all colorful, because for some students it's just distracting. But this is what we got. So as a recap, what have I done so far? Well, I looked at the equation. I got A, B, and C. I used the A value to fill in this part of the table. That was simple, just using this rule. 0 max, 0 min, 0. And then I found phase shift. As soon as I have phase shift, I have my first point. So negative pi over 9 and 0. Let me write that on the graph. Negative pi over 9 is there, and 0 is, of course, the y value. So I've got a point. Let me make it more clear. I'll make it in blue. That's my first point. If you don't have graphing paper, make a very clear sketch. You'll be expected to be able to do this on the assignment. So, how do we get the next point? The next point, we take displacement and add period over 4. So let me make it just a note here to the side. Or I'll write it here. Let's see. To get point 2. I'm only going to write this out once because I usually just do it on the calculator. Point 2, we take the displacement, pi over 9, add pi over 6. What's pi over 9 plus pi over 6? Well, I would take your calculator and just say negative 1 over 9 plus 1 over 6. And then put the pi back in. So I would say, you can do this as I do it. It's just as well you get to practice. 1 over 9 plus 1 over 6. I'm ignoring the pi because I can always put it in again at the end of my answer. So it's pi over 18. So pi over 18 is my next value. That's the x value. The y value is 0.5. Find it on your graph. Pi over 18 is right here. And the y value, 0.5. Okay, x value, pi over 18. Y value, 0.5. Connect the dots. Or, you know, put the pieces of the puzzle together. The rest should be pretty simple, honestly, but let's do it one point at a time. Take pi over 18, add pi over 6. You should get 2 pi over 9. I'll do that one more time. This is faster for you because I need to use my touchpad because this thing breaks otherwise. You have pi over 18, or in this case, 1 over 18. Actually, one way you could do it is if you already have your answer, just press plus and add 1 over 6 to it. The next number will be 2 pi over 9, okay? I'll add pi over 6 to it again. So plus 1 over 6. I'll give you my next answer. 7 pi over 18. 7 pi over 18. My next one, done the exact same way. I'll just take 7 over 18. I'm going to do it on my own calculator. Add pi over 6 again. And we get, oh, it didn't work for me. 7 over 18, add pi over 6, so 1 over 6. 5 over 9. This looks like a lot of work, but honestly, it's not. It's just following the same step over and over and over again. So let me fill in my x values. You can do the same thing. I'm going to look for this, 2 pi over 9 and 0. There it is. I'm going to look for 7 pi over 18 and go down by 0.5. And then I'm going to find 5 pi over 9 and put a point at 0. So those are my 5 points. And what I need to do now is just sketch between them, and I'm finished. So let me show you, before I sketch it, actually I'll sketch it first and then I'll talk about it. I'm not very good at sketching, so it'll take me a second. Make sure you try to get a curve. Don't make, don't make straight lines. And don't go any bigger than 0.5 or less than 0.5. All right. I said I wasn't too bad, but that's not so shabby. You know, I'm fairly happy with that. Okay. So you should have a curve that looks similar to that. And we're done. So before I ask you about your questions on this, let me just recap. Everything I did was based on this table. This is our cheat sheet. As long as you can fill in that table, you're okay. So let me show you. We know if we get the amplitude, I'll just make it in really obvious colors. If I get this amplitude, I can fill in min and max, okay? That's the first thing I can do. These zeros are always the case. If it's sine, they're always going to be there, so nothing to worry about there. This phase shift is the displacement. So you just copy that number in as the first x value. And then, once you have the displacement as your first value, you get your period, you divide it by 4, it'll give you this, and then you add it 1, 2, 3, 4 times to get your 4 different x values. Then you graph it. Just put the points on the graph paper and halas, we're finished. Okay, we'll do the whole story again. I'll write a little bit less on the page the next time. But is there anything I can clarify before I move on to a different example?
Yes, Mr.
If
About 0.2, if we multiply it by 2, we'll get 0.3.
no.
Okay.
What you need to go from one point to the other, to go from this point to the next point to the next point to the next point, you always add period divided by 4, right? So whatever your period is, divide it by 4, that's what you add. And it says that right here in the cheat sheet, okay? So let me give you an example of that. Let's just say that my displacement was 2, okay? Let's make it simple. And my period was 2 pi, okay? Let's just say that those are my numbers. So if I was filling in this table with x and y, who cares what y is, it doesn't matter. Your first number would be 2, because that's your displacement, and then you add pi over 4. So whatever this number is, you would divide it by 4, and you would get 2 over 4, so you get pi over 2 here. In this case, that's your period divided by 4. And you add it, so it'd be 2 plus pi over 2. So I just go to my calculator, and I would say 2 plus pi over 2. In this case, that you would have to keep it because that was not a very good example, but it would just be this. And then you'd add pi over 2 again for the next one. You'd add pi over 2 again for the next one. Am I making it clearer or worse?
Clear.
So that's for sine. And the difference between sine and cosine is very small. Remember, sine curves, let me just find some blank space here. I don't mean to keep going around and around and around. The difference between sine and cosine is that sine starts like this. It starts y-intercept of 0. That's sine. Cosine starts at 1 and then goes over like this. So cosine starts at 0, 1. Sine starts at 0, 0. Okay, that's the big difference. Everything else is basically the same. So what you'll notice in your table is that for sine, it goes 0, 0, 0. For cosine, it'll be slightly different. It'll be shifted a little bit, but the same basic rules apply. Okay, so I want to try another example here so that we can get a little bit better at this. Okay, stop me if you need me to. I don't mind going over it more slowly or repeating anything. All right, let's get to it. This is a sine curve. Right away, if it's sine, I know this. And I know this is where my maximum is going to go. Or in other words, I can say this is where my positive A is going to go, or my minus A, maximum and minimum. They mean the same thing. So what is A? A is 3. That means my amplitude is 3. Oh, I've already got my Y values. 3, negative 3. That's already done. I already know how big it's going to be. The next step is to get B. Well, B in this case is 1 over 2. Period I'll get in a second. C is negative pi over 8. Right, so hopefully you're okay with this. This is A, this is B, and this negative pi over 8 is C. All right, let's keep that in mind. So what do we need first? Really, I need displacement first, but it's hard to get displacement without period stuff. So I'm just going to go in the regular order. Let's get period. Well, period is 2 pi over B, which means it's 2 pi over 1/2, which if you work that out, you're going to get 4 pi. Okay, that's my period. I don't need period to do this question. What I do need is period divided by 4. So I'm just going to say period divided by 4 is 4 pi divided by 4, which is pi. Yeah, it's pi, Ahmed, it's not by. Pi. Pi. I know it's different. It's difficult in Arabic if you didn't grow up with it. You're of many, many students I have the same problem. Pi. So let me be clear here. Period is this 4 pi. It's this period on top that we're putting in as the period. Dividing it by 4, we get pi. So really, every time I get a point, I'm going to add pi. I'm going to add pi. I'm going to add pi. Let me put it over on the side so it's clear. My point 1, I'm going to add pi. And that'll give me my next x value over. Remember, I'm just going over by a quarter of the period, over by another quarter of the period, and so on. What's my first point? Well, I need displacement. Well, I need phase shift. My phase shift, or in other words, displacement, is negative c over b. I'm not going to make the same mistake again. Negative c, which is negative pi over 8, divided by b. B is 1 over 2. Now I'm going to use Ahmed's trick, because I like it a lot. Multiply the furthest numbers. So multiply negative pi by 2, you get negative 2 pi. And now multiply the closest numbers, 8 and 1, you get 8. Simplify this, you get negative pi over 4. Thanks for that, Ahmed. I'll use that for my other class too. It's nice. So that's my displacement. That displacement is what I put in here. How do I know that that's my first number? I know because that is the rule. If you look at our table, our displacement is the first number, and this is the displacement, okay? So these things all are pretty straightforward when you have the rules in front of you. I'll write down what the phase shift is here, negative pi over 4. Okay, What's pi over 4 plus pi? You can take your calculator. Pi over 4 plus pi. 5 pi over 4. Add pi again. You get 9 pi over 4. Add pi again. You get 13 pi over 4. Add pi again. You get 17 pi over 4. With denominators like this, you might notice that it adds the bottom number over and over and over every time. But I wouldn't trust that too much. Sometimes you might get into trouble if you do that, if you don't perfectly understand what you're doing. So let's just go ahead and add pi every time. So I'll do this just one last time. To get these numbers, you'll take whatever number you've been given. So in this case, I have negative pi over 4. I'm sure I just tapped that. Negative pi over 4, or you can just use negative 1 over 4. And I'm going to add pi. If you only want to use the numbers, you can just add 1. Gives me 3 over 4. Wait a second. I think I made a mistake. Yes. Yes. Yes, the negative. Let me make sure that I'm clear here. Oh, yeah. These are tricky. Obviously, you're watching me make little mistakes. It's because mistakes happen. There's little tiny things all over this, which is why we do the practice. So let me show you what the problem is. The C was negative to begin with. The formula has a negative in it. And so when we put a negative and a negative in, we should get a positive back. So it becomes positive. So what I started with was actually pi over 4, and now I'm okay. So just be careful. This was a positive pi over 4. The rest was okay. I just made a slight mistake with the signs. Try to pay attention. I don't try to make mistakes, obviously. But if I do make a mistake like that and you notice it, please let me know. We're almost done the course now. I'm not going to change. I'm not an angry guy. I don't mind if you tell me something, especially if you tell me something's wrong. Because if I make one mistake, I have a possibility of maybe 40 students making the same mistake because of me. That doesn't feel very good. So always tell me, all right? Other than that, I think we've pretty much got it. We've got all the points. Let's just sketch it. So I'll do it a slightly different way this time, just for funsies. I'll show you it's a shortcut. It'll end up being the same answer. Let's graph our first point. Where's pi over 4? Oh man, where's pi over 4? I'm looking for pi over 4. I don't even see it down here. Well, if this is pi, and there's 4 of these, 1, 2, 3, 4, this must be pi over 4. Okay, that's our pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. This actually would be 4 pi over 4, but we would cancel that, so we just call it pi. The next one's 5 pi over 4. I'm going to just write in ones that I know we're going to need. 5 pi over 4. Over here is 9 pi over 4. You could go up and say 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi, 13 pi over 4. Keep on going. And over here would be 17 pi over 4. And that's as many as I need. If you're doing this from scratch, you would see that yourself. That's the furthest we need to go. All right? So let me make them slightly different color, so you know that these are our special numbers for this question. All right, they match our x values. That's why I knew to use them. All right, let's fill it in. First point, pi over 4 and 0. It's right here. I'm going to show you a trick. Put in your last point. So your last point is 17 pi over 4 and 0. It's this one. And now just go halfway between them. You can count or whatever, well, we already have our numbers there. You can just look and get perfectly halfway. For sine, that's going to be a 0 point. If you go halfway between them again, you're going to have a maximum point. And then halfway between the other 2 points is our other maximum point. But of course, if you don't want to do the halfway thing, if that confuses you, just throw it all out the window and just copy from your table. You should be fine. Now I need to sketch it. Let me just double check that all my points are okay. This one here, pi over 4 and 0, is that there? Yes, it is. 5 pi over 4 and 3 is right here, and so on. They're all okay. So I'm going to start sketching. You should sketch as well. Practice this. When it reaches the maximums and the minimums, it should be perfectly flat. There's a ruler have pi. You're going to have to ask me that in a different way, Ahmed. I don't know what you're asking. You mean, is there like a ruler you can buy that has all the pi on it? Is that what you mean? No, unfortunately not. The questions that I give you on an assignment or a test, I'll go easy on you. You won't have to make your own notches. It'll be given, okay? So at the most, I know that you usually use your notebook. You won't need to worry, just copy whatever I give you on the assignment. If you can't print it, just copy what I've written exactly, okay? It'll already have all the pi numbers for you. Is that fine? All right, so hopefully you can see this is not so bad. It takes some time, but most of the time I'm taking is because I'm explaining every step. You know, the process itself actually doesn't take too long. And by the way, if you wanted to, some students like to fill up the whole graph. I don't know why, but some students like drawing this stuff. You can continue the pattern. You know, if you know you're going 1, 2, 3, 4, 5, you can guess where the next number is going to be. It's going to be over here. So some students go ahead and they'll continue the pattern and keep it going because they can't get enough sign for some reason. I don't know. So it's up to you if you want to do that. You don't have to. That's something you need to do. I'd like you to take a look at practice C. I just have a phone call. Someone's calling me again and again. Just take a look at C and see if you can get A, B, and C. Okay, sorry about that. It was Vodafone calling me over and over and over again, seeing if they can set up my internet. I'm busy, man. We're busy. People work, you know? Okay. So this is the next question. Maybe you've already got A, B, and C. It's very simple to get A, B, and C. A is 5, B is 3, C is pi over 2. And without even knowing anything else, you can just go ahead on autopilot and start filling some things out. So amplitude is 5. I'm not going to fill in this table yet for good reason. Period. Let's work on period. Let's see. Period is 2 pi over b. And b is 3. It's 2 pi over 3. Let's get period divided by 4. Let me write it a different way just in case, some students like different ways. I'm just going to take the period. I'm going to divide it by 4. I'm just going to take 2 pi over 3 and divide it by 4, and I get pi over 6. That's super important.
Minus pi over 6. Negative
For,
0.
for phase shift, yeah, I think so. For the phase shift is, yeah, negative c over b. That would be negative pi over 2 over 3, which is negative pi over 6. Did I do it again? No. Okay, I'm safe this time. This the one you were talking about, Ahmed?
Yes, yes.
Okay.
Sorry.
Perfect. No, it's fine. So I'm going to copy that, put it right here. Now let's make sure that everything's okay here. Let me follow my rule for cosine. Let's be very careful here. This is cosine. Cosine. Our rule for cosine, if you want your short way of doing it, it says right here, amplitude 0, negative amplitude 0, amplitude. So it should be our maximum, 0, minimum, 0, maximum. Or in other words, positive A, 0, negative A, 0, positive A. So I'll write those in. 5, 0, negative 5, 0, 5. That's a negative. Okay, Ahmed, you're the one who asked me about this earlier. How do I get the second point? What do I add?
Pi over 6.
Yes, good job. And it's this one, yeah?
Yes.
That's all you do. It's always that. So add this pi over 6 here. You're going to add pi over 6 each time, actually.
So 0.2 is 0.
Yep. And then adding pi over 6 to that is easy. It's going to be pi over 6. Add another pi over 6. I think you'll find, I want to be safe, it's 1 over 3, pi over 3. Add pi over 6 again, it ends up being pi over 2. Those look like really weird answers, but really, I'll just quickly write this in. This is just 2 pi over 6, which simplifies down to pi over 3. And this is 3 pi over 6, which simplifies down to pi over 2. So even though it looks like it's going through crazy numbers, 6s, 3s, 2s, it's just because that's the simplified version. You know, you can always make them bigger, but it's always nice to make them smaller. So that one was done much faster. You can see they're quite quick, as long as I'm not talking at you constantly. Let's sketch this. You know, I'll pause this. I guess I can't really see your graphs. So maybe it doesn't matter. Maybe you don't need to pause it. I was hoping I'd be able to see some of your work, but it's not so easy here. I'll just start graphing it. So this is more like something I would give on a test. You can see that all the points here are points that we're going to need to use. And it's nicely done for you. So let's just go ahead and do it. Negative pi over 6 is over here. Negative pi over 6 and 5 is right up here. Right away, that's different. Cosine starts at a top, at a peak, and comes down. We have a point at 0, 0. We have a point at pi over 6, negative 5. And here, and here, and here. And if we continued the pattern, we would actually even go down here. But you don't need to continue the pattern. You can just do the 5 points. Actually, I've done 2 more than I need. I got carried away. We only need 5 points, the first 5. I'm going to connect those and we'll be done. Once again, I'm not very good at sketching. That's why I make a lot of little lines. That's a cycle of cosine. It's not the best version. It's not the prettiest, but it's fine. It's fine. Let me show you what OneNote would show me if I was to graph this. Let me see if this is exactly what it's supposed to be. Let's see, it goes up to 5. Unfortunately, it didn't graph it in radians, but it shifted over from where it's normally, and it goes over to here. That point would be pi over 2. You know, this is about 3.14, so that's pi over 2. Yeah, this is the same graph. Desmos would tell it much, much easier. I don't know why I didn't do it on Desmos, actually. But I'm just confirming my answer is actually correct. And sine and cosine go on forever. There's no beginning and end to the sine and cosine function. They just kind of go on in both directions forever. All right? So that's how these are done. That's that first topic we'll do today. We'll do the second topic, which is a little shorter, and we'll be finished for the day. So is there any questions on this particular question?
No, sir.
Feeling okay? It's one of those topics that at the beginning, it's like, what are we doing? Why is he doing, how do I know this? How do I know that? But I think once you do them, they're not that difficult. It's the same process every time. Get your amplitude, period, phase shift, put them in the table, sketch your graph. And I want to be clear, these values here is what we add every time, period over 4. That's why it says period over 4 on the table. Okay, I think that's it for the practice questions. Any other questions, you can go and see Mr. Tom. We should just sketch sine and cosine graph. Yeah, so I think what you're asking is, do we need to sketch tan, cosecant, cotan, secant? No. All you need to do is be able to recognize those. So on your assignment tomorrow, I'm going to give you 2 graphs that you need to look at and tell me which one it is. Tan, cotan, secant, or cosecant. That's all for those types of graphs. For sine and cosine, you're going to have to do this, and you're also going to have to get the equation. But neither one is actually that difficult once you've done the practice. It's easy for me to say, but it's true. Okay, I'm going to move on. Ahmed?
There's only 2 questions tomorrow?
No, there are 4 questions. So the structure, the first question is actually, it's 2 questions. The first question has 2 graphs, and it asks you what's the function. So what I mean is what we did yesterday. I asked you, sorry, I'll just find it. Oh yeah, something like this. What's the function? So you'd have to tell me which one's which. Well, this one, if you know that this is not an easy function, then it's a secant. You should know that this one is an easy function, so it's a cotan. This one is not easy, so it's cosecant. Sorry, no, tan. This one actually is easy because it goes right through the center, and it's a secant style, so cosecant. So I'll ask you 2 of those graphs, and you just tell me which one's which. It's 2 marks each. It should be the easiest 2 marks, or 4 marks actually, easiest 4 marks you've ever gotten in this course. You're welcome. You're welcome. You don't need to graph those. I'm gonna scroll on down. You're welcome, Abdullah. Anytime. Where are we? Okay. So let's do page 32. And this says a lot on this page. I think it's trying to just give you a review, but most of what it says is not helpful. So all it's saying is you can get, given a graph, you can go backwards and get the equation, which of course you can. We just had the equation, we got the graph. So we do everything backwards and we'll get our answer. So what it's trying to say is amplitude gives the value of A. So if you look at a graph, find the amplitude by looking at it and you have your A value. B is found from the period. Of course that's true because period is 2 pi over B. Or let me make it easier on you. B is 2 pi over period. And then it says to find the value of C, we need to determine the displacement, the phase shift. That's all you need to do. You just need to see where it's moved from the original function. And it says something really sneaky down here. It says C is negative B times your displacement. It says that on bottom. It's not very well, it's kind of well hidden, but you can get this stuff. All right, so A is just your amplitude, B is 2 pi over P, C is negative B over D, and the most important things we need really are the amplitude, the displacement, and the period. So let's go ahead and do that. Example 1, I'm assuming you have this all written down, and maybe I'll give you one last piece of advice. I'm going to say it's a good idea, in fact, probably the best idea, to get amplitude, period, and displacement first. Once you have those three things, you can get the A, B, and C, and you can use those to make your equation. All right, so again, we want to determine a sine function to represent the following graph. So what we're trying to do is fill out this. It's a sine function. So use the sine, well, it's a sine function, so use sine, don't use cosine, is what it's trying to say. What is the amplitude? What's the amplitude? You can read it off the graph. Be very careful with this one. This is a little tricky. It's not 1, because that would be 1. This is 0.2, 0.4, 0.6, 0.8, 1, 1.2. Amplitude is 1.2. So A here, 1.2. Okay. I'm actually going to get periods next, and I'm not going to get the B value yet. I'll get the B value in a minute. From the graph, can you tell me what period is? There's many, many ways to get it. Can someone tell me what they think the period is? There's one way that's easier than every other way. Yeah, it's okay. It doesn't need to start from 0. This function has been shifted, but we can still find 2 points that are the same. So what I mean is you could find out the distance between this point and this point, but it wouldn't be so easy. You could try to find out the distance between this point and this point, which looks like maybe 3 pi. Or what I would recommend is just look at this point, but where it goes y-intercept, and go up, come down, and touch the same point. And we can read that. So I just saw some of you said that. Period is 3 pi. So that is, in my opinion, that's the fastest way to do it. Just look at your y-intercept and find another point that matches it. Just make sure you go up and down. You need to do a full cycle. If you wanted to, you could take, for example, this point, this is pi over 2, and you could take this point, that's 3, yeah. It's easier to make life easy for yourself, okay? So I would recommend taking the y-intercept. It'll almost always help you, and I'll always have it labeled. Okay, so period's 3 pi. Let's go ahead and get B while we're at it. So we know that period is 2 pi over B, which is 3 pi. Okay. So if we know period is 2 pi over B, and we know that period is 3 pi, so 2 pi over B must be equal to 3 pi. Same thing as we did before. Or in other words, we could just use B is 2 pi over period. So B is 2 pi over 3 pi, or in other words, B is 2 over 3. So we have A, we have B. All we need to get now is C. So I'm going to give myself a little more space. I didn't think ahead well enough. So I can do C. How do I get C? Well, I said earlier there's three things to get. There's amplitude, period, and displacement. Displacement is something we need to figure out where is the function compared to where it's supposed to be. So this one takes understanding. If you don't understand what a sine curve is supposed to look like, you're going to have a lot of trouble with this third step. If you know what it's supposed to look like, it's easy. So a sine curve looks like this. And the y-intercept is supposed to be right there at the origin. What we see in our case is it's been shifted to the right. So it used to be here, it's been shifted over to here. What is that distance? Well, it's not pi, it's half of pi. Because if we went this whole distance, it would be pi. We can see that. That whole distance would be pi. It's half of that, so that's pi over 2. So it's been shifted to the right by pi over 2. That's our displacement. Once we have that, we can find C. So C, I said, was what? Negative b times displacement. C is negative 2 over 3 times, that's not a 0, just so you know. Displacement's pi over 2. C is what? Negative pi over 3. Okay. We completed our mission. Speaking of which, did anyone see the space launch yesterday? Or was it yesterday? The day before? SpaceX? Cool. We're done. I showed you even more workings than you probably needed to see. But the whole idea was that we find amplitude by looking at how far the graph goes from 0. We find the period by finding two of the same points on the graph and seeing what the distance between them. The displacement, we look for the y-intercept and see where it has shifted. It says that here, look. If you're finding a sine function, the displacement is the horizontal distance from x equals 0 to the nearest root. See, let me do this one. This is found by determining where the original y-intercept is moved. I don't even know what it's trying to say after that. You just look for where the y-intercept is supposed to be and see what the distance is that it is now. Where did it move? How far did it move? That's your displacement. And you can write your equation on that. So let's finish our question. Y equals 1.2 sine b 2 over 3 x minus pi over 3. That's our final answer. If you're not sure where the numbers came from, let me just quickly make the colors proper. I won't do that every time because it's distracting sometimes, but just so you see where everything came from. All good? Is there anything I can clarify for this one before I do another example? Cool. I'll do another one. We'll find the same pieces. In fact, I want you to try it. They should only take you like a couple minutes. So I'm going to give you 2 minutes to see if you can come up with at least amplitude, period, and displacement, and even better if you can come up with the whole equation. Okay? Take 2 minutes. Okay, that's about 2 minutes. Did anyone manage to get any of the pieces? At the very least, you should be able to get amplitude. That'll give you a mark or so. Everyone still alive? I don't want to start unless you're with me. Maybe you're all getting something to drink or something. So the amplitude is the distance from the center. What's our amplitude? It's going to be 2. Period A is 2, period pi B 2. Yeah, Ayesha, that's perfect. You can keep going with that. If the amplitude is 2, then the A value is also 2. So we can already start building our formula. In fact, I'll just do that for fun. I'll do that over here. We already know it's 2, and we know it's sine of something. You've already got half our answer. C equals. Okay, good start, Juma. Period, what do we got? Period for this one is quite easy. We just can take 2 peaks. Take this peak and that peak. The distance between them is pi, so the period is clearly just pi. If that's true, B is very easy to get. Remember, B is just 2 pi over period, which is 2. Now we can get displacement, also called phase shift. The displacement is the trickiest one here. It's okay, Juma. No problem. The displacement's tricky. Let me get rid of the amplitude here, because it's pretty clear what that is. Negative pi over 2. Almost. If you're saying C, I think it's positive pi over 2. But let's take a look, right? Let's take a look and see what our displacement is. I'll draw the same picture. This is a sine curve. So sines normally look like this, which means that our y-intercept is usually there. The problem is, in our question here, that point is over here. So it's moved to the left. By how much? Okay, so Ayesha, you said you didn't know how to get it. This is for you. Normally y-intercept is at 0. Where is that point? It's over here. So it looks like -1, but be really careful. This is negative pi over 2, so it's half of that. It must be, what's negative pi over 2, divided by 2? Well, it's negative pi over 4. So this is actually negative pi over 4 is our displacement. That's a tricky one. Normally I would label the graph, okay? Just so you know. Negative pi over 4 is our displacement. Is that okay, Ayesha? Do you want me to show you a different way? Or explain it differently? Okay. So let me try to show it a different way. This is our sine graph, yeah? And when you look at this, what you'll see is that the y-intercept is right here. All right, that's what you start with. If the graph has been shifted, or in other words, if there's a displacement, you'll notice, just look at the graph. Just don't look at the C's and D's and stuff. Just look over here at the graph. If it's shifted a little bit, that point, that y-intercept won't be there anymore. Look at where it crosses the y-axis. It's now been shifted. It's over. It's moved. So there is a displacement. It's been pushed to the left. So there's a negative displacement. And we just need to find what that number is. So in our question, you'll look at this question here. I'll start it from scratch here. Our graph, we know, we've been told this is a sine graph. And sine graphs always start at when y is 0 here at the x-intercept. Sorry, at the origin. They're supposed to start there. This graph has been shifted. Look, this is really the function that we expect. It's been shifted over. Imagine the function should look like this, but it's been pushed to the left. Look, this is our original sine function. Someone has pushed it sideways. By how much did they push us sideways? They pushed us sideways by this much. And that distance is negative pi over 4. Normally, I'll label the axis, but in this case, you need to know from the information given that it's pi over 4. Is that more clear? Okay. So, yeah, I guess it really comes down to this big idea, yeah. So this is the sine curve, really. That's kind of what we're dealing with. That's like the template. It's supposed to be like this, but someone has moved it sideways. Just tell me what that distance we've moved is. And in this case, it's negative pi over 4. So let's get C. If it was cosine, it would be shifted to the right. Actually, if it was cosine, we just have a different looking graph. I'll just make it aside here. If it was cosine, it actually looks like this. And we just compare it. That's a terrible example, actually. 1 second. It has its maximum like this, okay? We just look and say, well, it's supposed to look like this. Has that been shifted sideways or not? You know, maybe it's over here. And we now need to figure out what this distance is, okay? But the same basic concept. Is that okay? It has nothing to do with it if it's left or right. All it has to do with is where it is now compared to what it's supposed to look like. It's confusing, I get it, but I'm doing my best. Some students also, they might say, hey, well, isn't this the start of the sine function? So shouldn't the distance be this? And that's perfectly fine too. You can actually use that displacement, but I find the shorter one to be easier. So that's the one I'm going to go with. I will make a quick note here though. Technically, it could also be 3 pi over 4. Just ignore me if you don't know what I'm talking about there. Okay, let's try to get C. C, we're going to take negative b times the displacement. So that's negative 2 times negative pi over 4. If you work that out, you get negative pi over 2, or sorry, positive pi over 2. We have our A, we have our B, we have our C, which means we have our answer. A, B, C. Okay. Hopefully that's getting more and more clear as we go on. A lot of students have trouble with trigonometry, I understand, but I'm doing my best to keep it as small chunks as I can. All right, let me move this up a little bit. I want to show you one quick graph, why C it's positive. So Abdullah, whenever we have our C value, positive C values mean the graph has been pushed to the left. Negative C values push them to the right. Because remember, anything in here with the X value, if it's positive, it actually has to do the opposite. It moves it left. So that's a bit of a tricky one. Remember how our horizontal translations work? That's why. Let me show you one more thing on Desmos. Let's make a clearer graph. So let's just say I had our original sine function. Okay, this is our sine function. Let me go and step by pi. this is our nice, simple sine function. I think you can all agree, hopefully, that that is sine, as we expected. I'm trying to get a better scale here. Just 1 second. Okay. This is our sine function, sorry. And now I'm going to graph, oh my goodness, sorry. I'm going to graph the function that we just made and compare it to it. So the function we just made was 2 sine 2x plus pi over 2. Okay, don't freak out. Just relax here. This is our original function. This is our new function. What has changed? Well, I can see that the amplitude used to be 1. Now the amplitude is 2. So that's what this amplitude does. We've got that accounted for. The period used to be from here to here. The period used to be 2 pi. And our new period is 1 pi. Okay. And finally, let me clear out the rest. Let me see if it's matching what we want it to be. We should be able to get our displacement from this. The y-intercept used to be here. That equivalent point is now there. Let's see what the value should be. It should be pi over 4. I'm going to zoom in on it. Actually, I don't need to zoom in. I can just use the power of Desmos. Bam, bam. Negative pi over 4. It used to be 0. Now it's negative pi over 4. Which numbers am I talking about? I'm talking about this. Okay, so hopefully that's a bit more clear. We're proving that the function we just made is indeed the function that I was given in the first place. So we transformed a graph into an equation. And in my opinion, this is way easier than Unit 3. In Unit 3, there was so much more to deal with. This is just a few small ideas that are slightly tricky, but I think you can handle it. In fact, I know you can handle it. Okay, let's do one more question and we'll finish for the day. How about that? Let's do a cosine question. If you have more questions after that, of course, I'm happy to help. So let's see, what's a good one? For example, see above, determine the cosine function. Let's do some of the practice. This is just more practice. You can go ahead and try those at any time. Let's try this graph below. Practice 2. It's the last question, actually, because the summary of trig identities, we didn't actually do that. So we're not going to do that page. Let's try this question. Hopefully it's not too difficult, huh? Hopefully it's a nice, easy one. I haven't done it yet. Okay. For the graph below, give the function in terms of cosine. Some of you will have almost the exact same question on your assignment tomorrow. Some of you. Take that as a hint. Okay, what do we got? Let's see what we got. We have amplitude. I should be able to see that straight from the graph, huh? And I can. It's 0.8. So A is 0.8. It's saying it wants cosine. So when I write out my formula, you better be very careful that you're writing cosine. If you don't write cosine there, you're going to miss some marks because it's kind of fundamental, the difference between sine and cosine. We have amplitude. That one's easy peasy. Let's see. Can we get period? Are you guys going to make me proud? Tell me what the period is first time. Am I going to get a chat filled with what the period is? What's it going to be? Shifted to the right. It is shifted to the right. Yeah. That's not quite my question yet, but I will make a note there about it. Ayesha, you got it. The period is 12 pi. How do I know it's 12 pi? Well, I'm just going to take the easiest point that I can. I'm going to look at this box. It would go whoa, and start again right over here at 12 pi. So the period is definitely 12 pi. From 0 to 12 pi, that distance. Or 15 minus 3. Perfect. Tarek, that's the first time I heard from you today, I think. It's nice to see you. you took this point and this point, which is perfectly fine. You took 15 pi minus 3 pi, which is also 12 pi. I'm going to erase all that in a second because I'm doing it a different way, but perfectly fine method. Nothing wrong with it whatsoever. In fact, if you wanted to, you could take this 18 pi and compare it to this 6 pi, and you would again get 12 pi. So it doesn't really matter which 2 points you take, as long as the 2 points you take are at the same point in the cycle. I like to take the x-intercept, sorry, the y-intercept, because it's just easier, in my opinion. So 12 pi, period from here to here. 12 minus 0. Let's go ahead and get b from that. B is 2 pi over the period. B is 2 pi over 12 pi. That means it is 1 over 6. I'm just going to double check my work here. Got a couple different things in the background, just making sure I don't totally throw you off base. Yeah, 1 over 6 sounds right. All right, 1 over 6. So I can actually complete more of my puzzle here. 1 over 6, x, or x over 6. I'll write x over 6 just to make it smaller. Excuse me. And finally, displacement. So Yaya said earlier, it shifted to the right, and I agree. And the reason is, this is not a sine function, this is a cosine function, so it should look like this. And originally, the cosine function has a peak right at the very first point. But at 0, at x equals 0, we have a peak. In this case, it's been shifted. How much has it been shifted by? Well, it's been shifted by 3 pi. It used to be at 0, and it's been pushed. Someone has pushed it to the right by 3 pi. So our displacement is 3 pi. And from that, we can get c. I'm going to do c the old-fashioned way, because some students get confused. Negative c over b is the displacement. That means negative c over 1 over 6 is 3 pi. Negative c is then 3 pi times 1 over 6, or in other words, pi over 2. Negative pi over 2. So whichever way makes you happy, you do that, okay? You find the method that works for you by doing the practice, and you should have no issue doing this. Wrong color. All right, plus, no, not plus, minus pi over 6, pi over 2. My brain is scrambled today. All right, let me color code this just as a final confirmation. And you should be able to see how all these pieces come together. Okay. Hopefully, wait a second. Yeah, 0.5. So this is the final answer. There's nothing else to do. Notice that it is in cosine terms. If I was asking for sine, it would be a different question. You would have a different shift. Shouldn't the displacement be negative 3 pi? No. Well, okay. So this is something that students definitely mix up. The displacement is like literally how it has moved. So when you look at this graph, it's moved to the right. So the displacement is to the right, it's just positive. The problem is when we go and find the c value, that's the one that's opposite. Okay, so when you actually deal with the c value, that's the opposite one. Displacement's not opposite. The displacement is just 3 pi, it's to the right, halas, we're finished. The c value is what gets this negative, okay? So that's a tricky one. but the reason for it is because it's the C value that goes into the formula, which is inside those brackets, which mathematically has to be the opposite, just because of things we saw in Unit 3. All right, so I'll stop the recording here. Hopefully that's enough to get you through. I mean, there's plenty and plenty and plenty of examples in practice, so you should have no issue. I'll keep this on the recording, actually. Tomorrow's assignment, just as a reminder, it'll be at the end of class. You'll have 40 minutes to do the assignment. You know, I'll probably finish at 3 o'clock, finish the class at 3 o'clock, and give you that half hour of the rest of the class to do the assignment, and then the other 10 minutes to finish off, okay? It'll be 4 questions. None of them are crazy long. The first question is, tell me what the graph is. The second question is, tell me what period, amplitude, and displacement are, given a formula, or given an equation. Pretty straightforward. The third question will be, graph the function, like we did our first thing we did today. And the fourth question will, no surprise, be get the equation from a graph. All right? So the 2 things we did yesterday will be on there. The 2 things we did today will be on there. And that's it. One single double-sided page. Double-sided paper. Okay? So I'll stop the recording here. If you have any other questions, you just let me know. Bye-bye, everybody in the cloud.